All right, transformations in the plane. So we're going to be analyzing figures to identify the types of rigid motions that are represented and find the coordinates of the vertices of images given the coordinates of the pre-images. So we're going to understand a lot of new words this time. But if you go find what page we are on, let me think if I can find the page here. We are on page 21 of your notes, transformations in the plane. Okay, a transformation is a function that takes points in the plane as inputs and gives other points as outputs. All right, in a transformation, the pre-image is mapped onto the image. These are all new kinds of words for us. It's funky. All right, what I want you to write, a rigid motion, also called a congruence transformation or an isometry, is a transformation that preserves distance and angle measure. Those are your fill in the blanks. Okay, so what I just said there, a rigid motion preserves distance and angle measure, okay? It's not changing shape or size, okay? That's what this means. Okay. Now, other things I want you to see. I'm in the wrong thing. The pre-image is shown in blue. And the image is shown in purple in the next few slides. Okay? Prime notation is used to indicate transformation. So, if A is the pre-image, then A prime is the image after one transformation. So what that means is when you see this tick mark, that indicates a transformation has occurred. Nope. I never remember if I need 1C or 2. You guys will have to correct me here if I mess it up. Okay, so let's look at what this looks like. Here's the 3 major types. You've got them in your key concepts. A reflection, or a flip, is a transformation in a line called the line of reflection. Here, this line of reflection, it's this thing right here. That's your line of reflection, okay? It's not always necessarily drawn in. You have to imagine it. It sits between where the image was. This is the image. Or sorry, wait a second. I wrote that wrong. This is the pre-image. And this is the image. Okay? Okay. And when I say pre-image, I mean where it used to be. And image means where it now is, where it's moved to. Okay? A lot of times we reflect across an axis. We might reflect across the x-axis. We might reflect across the y-axis. Many times across an axis. Y-axis. X-axis. There you go. Nice bell. Okay, A translation or slide is a transformation that moves all points of the original figure the same distance in the same direction. So it's sliding that sucker, okay? And a rotation or turn is a transformation about a fixed point. A fixed point. See that fixed point right there? There's your fixed point. Many times the origin. Called the center of rotation, through a specific angle and in a specific direction. Each point of the original figure and its image are the same distance from the center. Okay? So if I was to, let's see if I can do this. If I were to go from this center point out to A, there we go. And then from the center point out to A prime, those are the same length, the exact same length, okay? Like here we go, look at those, exact same length. If I measured them, got out my ruler, the same length. They just have an angle between them. They have rotated a certain amount, but they are the same length. Okay. So let's look at this one. Example 1. In this picture, this landscape is an example of a reflection. You can see that right here. There's our axis. And we see the mountains below or above and below. Beautiful. So in this one, your practice, in checkers, people move their pieces in a diagonal. Is that a reflection, a translation, or a rotation by your understanding? Go ahead and write it down. Or circle it, actually, yeah. Which one of these? Hopefully you circled that it was a translation. Definitely translating it, sliding your piece. Okay? Identify the type of rigid transformation shown here. So if we went from, let's say all of these went from blue to green. So if I went from this blue to this green, what happened? It appears as if it slid. It appears as if, like, this point slid to that point. So I would call that a translation. Now this point B, this one appears as if there is a line of reflection right there down the middle, and it reflected across it. The whole thing got flipped. And C, so this one's reflection. C is definitely rotation. This one, if you go from here to here, and from here to here, definitely rotated around 90 degrees. All of the points did. Can go back to the origin here. All of them rotated 90 degrees, and I could draw lines to all of those vertices, and they all rotated 90 degrees, all in the same direction. There we go. Yep, translation, all the same distance, reflection, and rotation. Okay, so you do this one. What is that? Go ahead and pause me, write it down. Hopefully you wrote down that that was a rotation. It definitely rotated up and over that way. All right. So let's talk about reflections. In a reflection, each point of the pre-image and its corresponding point on the image are the same distance from the line of reflection. The segment that connects a point on the pre-image to its corresponding point on the image is perpendicular to the line of reflection. Okay. I'll show you what that means. Okay, and a reflection can be described as a function in which the pre-image is reflected in the line of reflection. The points of the pre-image are the input, and the corresponding points in the image are the output. This is kind of an algebra description. Okay, inputs and outputs, and how they look at that is right here. And we'll look at the math with that, okay? So if we reflect in the x-axis, so the words that you might hear is we reflect across the x-axis, or reflections in the x-axis. So for instance, here's our segment. Segment AB is reflected across the x-axis. So the pre-image is up there, and now here's the image down here. So we see A prime and B prime down there. That's how we use those terms, A prime, B prime. Notice what happens to the points. We started at 4, 1. Now it's at 4, negative 1. We started at 7, 3. Now it's at 7, negative 3. So you can start making a guess as to what happens when you reflect across the x-axis. The y value becomes negative or changes its sign. Or in words, to reflect a point in the x-axis, multiply its y coordinate by negative 1. So you're going to change the y, change the sign of the y. So this is the key concept. If we're going to reflect in the x-axis, change the y sign. This is worth keeping in mind. Now, when we reflect in the y-axis, I bet you can make a guess what happens. Yes, we are going to change the x sign. Here it is. So when we reflect across the y-axis, the x value changes. Now, up a few slides, I talked about being perpendicular to the line of reflection. And here's what I meant, was that if you trace the line of reflection, so here's my line of reflection, and then you connect my pre-image point to my image point, they will be perpendicular. So if you're not quite sure where the line of reflection is, you can connect the pre-image to the image points, and the line of reflection will be right down the middle at a 90 degree. The other thing that you'll see, this is kind of cool, is that this and this segment will be exactly the same length, and this segment and this segment will be exactly the same length. It will be exactly in the middle of there. So you can always find the line of reflection if you're not sure where exactly it is. Okay. So let's try an example here. triangle ABC has coordinates given. Determine the coordinates after a reflection in the x-axis. So reflection in the x-axis goes like this. X, y changes to x, negative y. That's our rule. Okay? And if we're going to do that, they went ahead and drew it out for us, which we've got on your paper for you. So we're going to predict it. Before performing the reflection, predict your results. So if we're going to reflect in the x-axis, that's going to be here. With that,
Lunch day students, you can head on down.
that means the A is going to go that direction, the B is going to go up, and the C is going to go up, right? Because they're reflecting, they're going to flip. So here they are. I like to write them out exactly like this. I write out my rule on top, I write out my 3 points, and then I go ahead and I write out the changes right here. And those are my 3 new points. That's exactly like I like to write them. In fact, if you're writing this out on your paper, this is what I would write. There you go. Pause it if you need to. Okay. And then I check. Yep, those did flip it the other direction, yeah. Now if I'm doing reflect in, or the part B, if I'm gonna go across the y-axis, now they're gonna come over here. And my rule is x, y goes to negative x, y, because my x-axis, or my y-axis stays the same, it's my x that changes. My y values stay the same. So that's what I would write out exactly. And these are the values that change. See that? Those ones, they get the negative. That's what I would write out for the y-axis ones. And I would draw those out as well. And they look great. Okay. Now go ahead and do practice 3. Pause me and see how you do. Did you come up with letter A? I sure hope you did.